Hi, so we're going to continue working on Pythagorean theorem, just like you did yesterday. Yesterday was really about getting the formula, understanding where your hypotenuse is and where your legs are, and how to deal with the actual theorem to find your answers. And so what we're going to do today is we're going to take that one step further and we're going to look at application questions. What that really means is we're going to be applying what you did yesterday with word problems. So you'll notice the very second thing it says is to do exactly what you've done before. Nothing is changing. What's changing is the way the problem is given. So what we're going to do is we're going to change that into what we're used to. And we're going to do that by what it says first. Draw a picture with the correct labels. Once you have that picture drawn, it turns into exactly what you did yesterday. And I know a lot of people get really frustrated and confused when it comes to word problems. So if you can just remember that the problem itself is the exact same that you did yesterday, it's just shown a different way. And if we can make it look the way that we're used to with the picture and with the labels, then really nothing has changed. So let's try a few of those. So here it says, what is the length of the diagonal of a rectangular picture whose sides are 12 inches by 17 inches? Round to the nearest tenth of an inch. And we're not going to round. We're going to do what we typically do, and that is we will pick the closest perfect square that it is closest to, and that's how we're going to solve these. And again, I'm starting with the picture. So it says I have a rectangular picture. So I'm just going to come over and draw a rectangle here. And one of the sides is 12 inches and one of the sides is 17 inches. And what we want to find is we want to find the diagonal of it. So when it talks about that diagonal right there, it's actually that's what we're finding. And what you can probably see now is here is that right triangle that we dealt with yesterday. And here I've got my two legs because this is my right angle. So I've got my two legs, and what I'm finding is the hypotenuse. So now that we have our picture, let's just do what we did yesterday. A squared plus b squared equals c squared. And we're going to plug in our 12 and our 17, and it's going to equal the hypotenuse. And remember, we've talked about it, that the more that you have memorized as far as your squares go, the easier this is. Hopefully y'all have 12 squared, which is 144. And if you didn't, you could go over to the side and actually multiply that out. Same thing with 17 squared, which it does equal 289, and that's going to equal our c squared. So at this point, I'm going to use our order of operations, and I'm going to add these together, which is 433, and that's what c squared equals. Now remember, we're not wanting that. We're not wanting c squared, we're wanting c. So what we're going to do is we're going to try to think, after we take the square root, is the two perfect squares that this is closest to, what it's in between. And it's going to be in between 400, which is going to be actually 20. And then it's also going to be in between 21, those are the two numbers, which is 441. And again, you just get better and better with these perfect squares the more and more that you use them and the more and more that you study them. If you haven't yet made flashcards of the first 30, that's something that you definitely want to do, and start getting those a part of your memory bank quickly. So these are the two numbers that it's closest between, 400 and 441. The square root of 400 is 20. The square root of 441 is 21. And so here we're looking to see, well, which one is it closer to? It is closer to the 441, so we're going to say our answer is about 21. Okay? All right, let's try the second one. Troy traveled 8 miles due east and then 5 miles north. How far is Troy from his starting point? Round your answer if we need to. And again, we're not going to round our answer. We're going to do what we've done in the past. So here's Troy's starting point right there. And it says he travels east. Okay, east would be this way, 8 miles. So that is 8 miles. Now he travels north, which would be up, and he travels 5 miles. And what we're wanting to know is, well, what is his distance to his starting point? So right there. So again, we are finding the hypotenuse. There's that right angle. So now that we have our picture, let's go ahead and figure out what that hypotenuse is. A squared plus b squared equals c squared. Let's plug in our legs. Oh, I'm sorry, I'm jumping ahead. You'll start to do that too. You'll start to skip steps like this, which is not good. I should not teach you that. All right, so now we will actually square these numbers, which would be 25 and 64. And now let's add those together, which would be 89. So at this point, again, we need to take the square root. Okay, this is not a perfect square, so let's think about the things that's in between. Well, my two perfect squares that's in between is 81 and 100, which would be in between 9 and 10 for the square roots. And it is closer to the 89, so we're going to say that this answer is closest to 9. It's about 9. Wonderful. Do one more. What is the perimeter of a right triangle? Okay, we know we've got a right triangle, and notice we are finding the perimeter. The hypotenuse is 15, and one of the legs is 9, so we are finding a missing leg here. So a squared plus b squared equals c squared. Let's plug in what we know. We know one of them is 9. We don't know the other, and we know the hypotenuse is 15. Let's go ahead and square these numbers to 25 and 81. Now I need to subtract 81 from both sides. That will leave me what b squared is. That would be 4. Let me borrow. That would be 144. Perfect. And we take the square root, and this one it ended up being a perfect 12. So as you can see, nothing different from yesterday. Once you draw that picture, you plug it into the Pythagorean theorem, and it's just more and more practice. Good luck, you guys.